if you want to talk, you can always just unmute yourself. Okay. So it's nice to see everyone again. Well, I guess just Anthony again. It's my first time seeing you, Ryan. Ryan, you mentioned that you learned a little. You mentioned you learned a little bit of grade 9. Sorry. Yeah, you mentioned you learned a little bit of grade 9 math before already. So I'm guessing you learned about the equation of a line and how to interpret those equations, right? Like we say y equals mx plus b. This isn't news to you, right, Ryan? You've seen this before?
Yes.
Yes? Oh, okay, great. In that case, this might actually be the right level for you. Okay, generally speaking, the first thing that you learn is linear systems. I think, Anthony, you've probably already seen this before. Again, I'm not 100% sure if you want to super pay attention in this class because when we do the lesson next week, we're going to have to do this lesson again, right? So it's almost like you're getting listening twice. So, pay half the attention. That's enough, okay? Next class, you can pay full attention because I know how boring it is to learn the same thing twice. I myself hate doing that, okay? So if you need to go to the washroom, just go. Learning the same thing twice is always a little painful. But what happens is right now we're dealing with linear systems. You guys have done this back in grade 9 already. That's the good news. In grade 9, when you're doing linear systems, usually they ask you to do it graphically. So that means if they provide you with 2 lines, they say y is equal to 2x plus 1, and they say something like y is equal to 3x minus 5, for example, and they want to know where these 2 lines intersect. The solution is going to be their point of intersection, right? So again, if we were to just sketch out a very, very rough sketch, we know that 2 is the slope, and the 1 is the y-intercept. Okay, hopefully everybody remembers that. Y equals mx plus b, where m is the slope, y-intercept is the b value. So we have 2x plus 1, so it's going to look something like this. Okay, again, we're just sketching it right now. And 3x minus 5 is going to start at -5, but the slope is going to be a little bit steeper because it's got a slope of 3. And essentially, wherever these 2 lines intersect, that point of intersection is going to be the solution. Okay, because this point of intersection is guaranteed to be on both lines, right? That x and y coordinate will be on both lines. So therefore, the idea behind solving for linear systems graphically is to look for the point of intersection that satisfies both equations. Generally speaking, the graphical solution is the worst one because it takes the longest to do. And you have to graph it really, really precise in order to get an answer, right? So that's why most of the time in grade 10, we try to focus more on doing it by either substitution or elimination. So we want to solve it algebraically. Again, the solution is quite simple. Once you guys have seen it, probably all of you will be able to do it very, very easily. The only hard part about grade 10 math for this part, for the linear system, is just word problems, okay? So if you get really good at interpreting the word problems, the rest is nothing. The rest is just very, very basic algebra, okay? So again, the first part is about representing linear relations. Hopefully you guys already know this, but a linear relation is composed of an equation that generally has the form y equals mx plus b. This is known as the slope-intercept form. You can also write the linear equation in something known as standard form, which is given over here, ax plus by plus c equals 0. Generally speaking, though, standard form is not very useful. So we usually prefer to rewrite everything in the slope-intercept form. Because the slope-intercept form gives us a lot more information, we can actually use this information for graphing. Whereas in standard form, you kind of can't really do anything with it. So I would recommend that when you think of equation of a line, to always think of it as y equals mx plus b. This is going to be kind of like the default that we will, generally speaking, be working with. Okay. most of these questions are fairly easy. We're not going to do all of them. Okay, like it's just kind of a waste of time. For example, number one, which of these ordered pairs are not points on the graph 2x plus 4y equals 20? Well, obviously, you just plug all of these into your equation. And whichever one doesn't work is your answer, right? So, for example, when x is 10, 2 times 10 is 20. 4 plus 0 is 0. That's equal to 20. Okay, so that means 10 and 0 is on the solution, is okay. That's on my line. Okay, you do the same thing with all of them. See which one's not on your line. That's your answer. Okay. So generally speaking, this is the idea behind a linear system, a linear relation, rather. A linear relation must composed of just a single y, so y to the degree power 1. And then the x must also be degree 1. Okay, because eventually in grade 10, you guys are going to come across something called quadratics. That's when you have something called x degree 2. Okay. So that's how you can kind of distinguish the difference between a line and a quadratic. A quadratic is going to have an x squared. A line is only going to have a single x. Okay, and again, it might be kind of straightforward. It's kind of common sense for everybody, I think. But that's just basically what they want you to know for the purposes of this lesson. Okay, so let's practice writing a word problem or an equation in terms of linear relation. So the student council invested some of the money from a fundraiser in a savings account that pays 3% per year. The rest of the money in a government bond that pays 4% per year. Investments earned $150 for the first year. So if you guys are in high school, I know Ryan's not, but if once you get to high school, remember that one of the most important things is that unfortunately in high school, a lot of your marks isn't just going to come from the answer. Okay, so the way you write your math is really important too, right? So the first thing that you want to do in any word problems, you have to define your variables. If you do not define your variables, you will lose 1 mark. Okay, so for example, if this question is out of 3, if you don't define your variables, you can automatically only get 2 out. Okay, so the first thing we want to write is let x represent amount of money invested in savings account. Okay, and then similarly, we can let y represent amount of money invested in the government bonds. Okay, so now we have defined our variables, now we can write the equation. The equation is very easy because we can see that the savings account pays me 3% per year, so that's represented by 0.03x. And then the savings bond pays 4% per year, so that's 0.04y. And the grand total interest is $150. So this is my equation. 0.03x plus 0.04y is equal to 150. And now we're able to plot that line on the graph. And then we can kind of figure out what are the different possible combinations that we could have put in the savings bonds and government bonds that will result in interest of 150 at the end of the year. Okay, so there's obviously going to be a few different combinations that we can put. And this straight line will be able to tell us all the different possible combinations. So don't forget, if this question had some calculations, at the end, you want to write a concluding statement. So you want to write therefore, blah, 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 blah. Okay. So in high school, the marks are kind of wonky, okay? But you get 1 mark just for the let statement. Basically, you probably get about 1 mark for showing the correct process and getting the right conclusion. Okay, maybe 2 marks. Okay, 2 marks for process and conclusion. And you're probably going to get 1 mark just for writing this concluding statement. Okay, so this is the biggest problem that I run into with really smart kids, such as yourselves, is that the really smart kids never want to write things in full because they can just figure out the answer right away by looking at it. And then they end up not getting full marks in the communication. They can only get like a 90 or something. Make sure you guys write out everything in full, because if you guys deserve 100, you shouldn't settle for 90. Okay. All right, let's take a look at solving linear equations. Solving linear equations, this just means a single equation. That just means isolating for the variable. I'm 99% sure that if you guys have gotten to grade 9 math, you must have already isolated and solved for a variable. Okay, so I'm pretty sure you guys already know how to do this. I don't believe we will need to review this too much, but let's double check. Let's check one question. Okay, let's pretend we're doing number 7. It says Hank sells furniture and earns $280 per week plus 4% commission. Determine the sales that Hank needs to make to meet his weekly budget of $900. So the first thing we should do is we should write the equation. Okay. I'm not sure why B is write the equation. The first thing we should do is write the equation. We just flip these two. Okay, the first thing we should do is write the equation, then you can determine the sales. Okay, so if we wanted to write the equation, we should once again define our variables. Because we could say let X represent amount of sales. And we can say let Y represent his profit, okay, how much money he makes. Okay, so that means the amount of money that he makes, Y, is going to be equal to 4% of his sales, so 0.04 multiplied by X, where X is how much money he made in sales. And then he also earns $280. This $280 is a flat fee. So in other words, it's the initial value. Even if he sells nothing, they still have to pay him $280, right? So once again, this is the equation of a line, y equals mx plus b. Now, if we want to know how much sales he needs to make $900, we just need to let 900 equal to y. And then afterwards, we isolate for x. Okay, this next part should be relatively straightforward for the majority of you. I'm not sure what that is. 620 times 35. 10, 3, 1, so 4, 1, 2, 1,005. Okay, it looks like he needs to make 15,000. Does that make sense? 15,000 sales? It's not too much. Let's just use a calculator. Uncle Michael's mental math is not good today. Let's see, 620 divided by 0.04. Oh, there's 15,000. Okay, I was right. That seems like a lot of sales just to make $900. But I don't know. I'm not sure what he's selling. Okay, maybe he's selling cars, in which case $15,000 is like nothing, because every car is at least like $40,000, right? So he needs to make 15,000 in sales in order for him to make his weekly budget requirement of $900. Okay, so this guy has to be pretty good at selling. Hopefully all of you understand how to isolate for variable here. Hopefully there is no confusion about this. Ryan, is okay for you? Easy?
Yeah.
Okay, good. All right. Let's do one that could be a little bit harder. Okay. So let's do number 12. Okay, it says at 9 a.m., Chantel starts jogging north at 6 kilometers per hour from the south end of a 21-kilometer trail. At the same time, Amit begins cycling south at 15 kilometers per hour from the north end of the same trail. Use a graph to determine when they will meet. Okay. So again, unfortunately, they do want us to use a graph to do it. It is a lot easier if we do it by algebra, but we'll come to that really soon. So we know that Chantel jogs at a rate of 6 kilometers per hour from the south end of a 21-kilometer trail. So we can kind of assume that she's going to start here at the 0, and she's jogging north at 6 kilometers per hour. Okay, and then the other person is going to start at the very top part. So it's going to start at 21. And then, but he's riding a bicycle, so he's going a lot faster. So he's going to be a lot steeper. Something like this. And then the question is asking, well, when are they going to meet? Okay. Again, we're not drawing this on grid paper, so this is going to be a little bit hard to see. But they will meet after 1 hour, if you think about it logically, because after this person traveled 1 hour, they'll arrive at the 6 kilometer mark. And after this person travels 1 hour, they will arrive at the 6 kilometer mark because this person is going 15 kilometers per hour. Okay, but if we did have graph paper, then they would intersect at point 1 and 6. We don't really have graph paper online, unfortunately. I guess I could just find one on Google Docs, but I don't think it's necessary. Honestly, when I do these lessons on Zoom, I don't really focus too much on the graphing. The graphing, I'll probably assign a few questions for you guys to do for homework, generally speaking. But it's just a lot easier for us to focus on the algebraic solution for linear systems, because that's the one that everyone uses, right? It's a lot faster, it's cleaner. You don't have to make your lines picture perfect. Okay, so again, we already talked about this. When we're solving linear systems, you're basically, each line will be represented by one of your conditions, and you're basically looking for the solution that's going to satisfy both conditions, right? So when we find that solution, we will plot them together as a linear system. Again, the basic idea behind it is really easy. It's only the word problems that are going to be a little bit more challenging. Okay, so let's try and solve one of these by graphing. I'll try my best to sketch it as accurately as possible. Okay, so the first thing that I like to do is I always like to just rearrange it into the slope-intercept form. I just like it a lot more. Okay, so I like to just rearrange everything into the slope-intercept form and then graph my graph from this. So I'm gonna have to try and put this to scale a little bit. Otherwise, the drawing is gonna be all off. Okay, so I'm gonna try my best to scale this. 1, 2, 3, sorry, negative. -4, -5, -6, and -7. Okay, I think that's pretty close. And then we have 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. And then -1, -2, -3, -4, -5, and so on. You get the point. All right, so let's sketch the first one. Let's sketch that one in red. Y equals to -x plus 3. So remember, you're going to start at the +3, and then you have a slope of -1. This means your slope is -1, and your y-intercept is at +3. So when you have a slope of -1, you need to go 1 down and 1 to the right. So that means your next point is over here. So we can go ahead and connect our lines. Okay, so we should have one line that looks like this. And then for the other line, let's do it in purple. Okay. We have x equals to y equals to x minus 7. So that means you start at -7. And this time you have a slope of +1. So that means you're going to go 1 up and 1 to the right. And now we're going to go ahead and connect those lines. I don't know, maybe something like this. Okay. And then we will have our point of intersection over here. Okay, so that point of intersection, I believe right now looks kind of like, what is the actual solution? Let's see. I'm just going to cheat a little bit here. 42, so y is at -2, x is at x is 5, so it's 5 and 2. We're just going to cheat a little bit here. Okay, I'm going to draw my line so it's a little bit better. So we have 7 and then 1, and then when I connect my lines, it's going to connect like this. Okay. So we got a point of intersection over here. This coordinate is 5 and -2. Okay, now we can check it. Does -5 plus 3 equal -2? Yes. Does 5 take away 7 equals -2? Yes. So therefore, this point is the solution to my linear system. Again, I kind of had to cheat because I had to solve it algebraically because my graph didn't really look like it was going through 5, -2 the first time. So that's why you need graph paper to do this. So it's really annoying to do the solution for linear systems by graphing. So nobody likes it. That's why we focus on the algebraic solution. Okay, so let's skip ahead and let's learn about how to solve this with algebra instead. And again, some of you may already know this. A lot of the times, the students doing more advanced math, they've already seen these solutions. But the first method that I'll teach you guys, well, let's just start with elimination first. Okay. When you want to use elimination, you basically want to choose one variable to eliminate. Doesn't matter which one you choose. And then you want to make sure that they have the same coefficients. The coefficient just means the number in front of the variable. Okay, so in this case, it doesn't really matter. We can eliminate either one. So let's suppose I want to eliminate the x's. If I want to eliminate the x's, then I should just subtract the two equations, right? Because x take away x is 0. So I don't have any more x's. And we have y take away -y, which is positive 2y. And then 3 take away 7 is -4. That means y is equal to -4/2. So y must be equal to -2. Now that I've solved for my y coordinate, I can simply replace it back into any of the equations, either this first one or the second one, doesn't really matter. And then you will get your answer. So we have x plus -2 equals 3. X must equal to 3 plus 2. X equals to 5. And that's the exact same solution that we got before, right? We set the point of intersection was at 5 and -2 before. So we can also do it by elimination. It's a lot easier and it doesn't require you to make super accurate graphs. The second method that you can use is known as substitution. This method is, generally speaking, considered to be a little bit slower, but not always. Okay? Sometimes it's actually a little bit faster. But usually people prefer elimination. So most of the time people prefer the first way. The second way of doing it is to just isolate for a variable. So for example, if we look at our first equation, we said x plus y equals 3. It stands to reason then that x must be equal to 3 minus y. All I did was bring a y to the other side, right? Now that I know that x equals 3 minus y, I sub it into the second equation. Okay, so right now my second equation says x minus y equals 7. I just replace the x with 3 minus y. So we say 3 minus y equals 7. So that means 3 minus 2y equals to 7. So once again, we have -2y is equal to 4. Y is equal to 4 divided by -2. Y is equal to -2. So because if you get the exact same solution as before, replace the y equals -2 into either one of these equations, and you end up with x equals to 5. Okay. Again, I believe most of you will have seen this already at one point or another. Ryan, have you seen this before already?
A little bit.
A little bit? Okay. Well, as long as you've seen it before, that's actually a good thing. And if you haven't seen it too much, that's also a good thing, because then it probably means this is the right level for you. This is the correct class for you to be in. Okay. So this is the idea behind solving for linear systems. On the test, if it says solve by graphing, you must graph. Okay, you have no options. I know you guys might like the algebraic solutions more, but if the test says solve by graphing, you must graph. If the question just says solve, then it's your choice. Okay, how you want to do it. generally speaking, most people will choose elimination. Okay, but we're not going to graph. Okay, I hate the graphing solution. The graphing solution is really nice to get a nice visual of the problem in case you're a visual learner. But to always do the graphing solution is going to take a long time. So that's why we learned the algebraic solution, and most students do prefer it. Okay, so as you can see, the process wasn't too hard. And again, I'm going to just do one more for you guys because you guys might not be too familiar with it. And then we will move on into some word problems. So again, we have x plus y equals 8. We have 4x minus 2y equals 8. Okay. Suppose I wanted to solve this algebraically and not graphically. The first thing I need to do is I need to make sure that they have the same coefficient. Okay, so that means if I want to eliminate, let's say, the x's, then in order to make the x's the same, I should multiply this entire thing by 4 on both the left side and the right side. So in other words, my equation essentially becomes 4x plus 4y equals to 32. Now that the two equations have the same coefficient for the x's, I can subtract them. 4x take away 4x is 0. Negative 2y take away 4y is equal to negative 6y. And 8 take away 32 is negative 24. That means y is equal to negative 24 divided by negative 6. So y equals to 4. Now that I solve y equals to 4, we can plug it back into the first equation or the second equation, and we end up with x is equal to 4. Now, when you have time on the test, you should always check your solutions. So 4 plus 4 is 8, that's correct. 4 times 4 minus 2 times 4 is 8, that is also correct. So therefore, I know 4 is the correct point of intersection between these two lines. Generally speaking, there's no excuse to get these questions wrong because you're literally able to check these answers yourself just by plugging it back into the original equation, right? So if you have time on the test, always double check your work. It's going to save you at least one time, okay? Well, sometimes you'll always, like 99% of the time, you'll probably get it correct the first try. I'll probably save you at least one time. Okay. So let's take a look at some word problems now. Okay, this is when you guys have to teach me. Okay, so we already talked about how we can solve the problems when they give you the equation. When they give you the equation, it's super easy, right? So the only hard part is in grade 10 for these questions at least, the only hard part is how do we translate the English words, the word problem, into the equation, right? So let's start off by defining our variables. Ryan, can you tell me what I should let my variables be? So what should x be? What should y be?
X should be 200 kilograms.
Oh, not quite. Very close. So when we're trying to define our variables, we always need to first think about what the question is asking us. So it says how many kilograms of each kind of bean. So let's say that there's two kinds of beans. The first kind of bean is sells for $15 per kilogram. And the second type of bean sells for, sorry. First type of beans, the Brazilian bean sells for 12 kilograms. Ethiopian bean sells for $17 per kilogram. So because the question is asking us for how many kilograms of each kind, we should let x represent the amount in kilograms of Brazilian beans, for example. Okay. And then we should say let y represent the amount once again in kilograms of Ethiopian beans. Okay, so if you're ever struggling to figure out what to define as your variable, the answer is simple. You look at what the question's asking you for. It says how many kilograms of each kind of beans. So we don't really know how many kilograms are in each one, right? That's why it's asking for them. So that means let X represent one type of the beans and let Y represent the second type. Okay. So if ever you're having a hard time defining your variables, always just look at what the question's asking you. Now that we have our variables defined, we can then create our equations. Okay, the equations are going to be two linear relationships. Okay, the question will always give you enough information to make two equations at the minimum. Okay, so Anthony, can you tell me what one of the equations might be in this particular question? What can my first equation be and what might my second equation be? Anthony? Yeah. What do you think one of my equations are? I think you're muted. Maybe you're talking.
No, I just completely forgot this unit.
Oh, you've done? Okay, that's okay. It's not a big deal. Okay. If you forgot, it's even better, right? Isn't that because then it's like actually interesting to learn, because otherwise it'll be boring. Ryan, do you think you can tell me what one of the equations might be? What one of the conditions?
X plus Y equals 200 kilograms.
That's good. Really smart. Because we have X amount of Brazilian beans. If we add that to Y amount of Ethiopian beans, we know the grand total has to be 200. So we're trying to make 200 kilograms worth of this blend. And then this blend, we're going to sell at $15 a kilogram. So now the second equation is going to be a little bit harder. I'm going to help you guys with the second equation. A lot of times when kids are doing it for the first time, they'll have a hard time with the second equation. The second equation is just the same thing as the first equation, except you multiply the price into all of it. Okay, so it's nice and easy. It's not hard once you get used to it. But we know Brazilian beans sells for $12 per kilogram. So the amount of money I'm going to make from Brazilian beans is 12x. Okay. And then the Ethiopian beans sell for $17 per kilogram. So we're going to go 17y. And that mix is going to end up selling for $200 times 15. Okay, because I have 200 kilograms of my final mix that I'm going to sell for $15 per kilogram. So in other words, the amount of money that I'm putting in from my Brazilian beans, because it's in dollars, right? Because it's $12 per kilogram. If you think about it, $12 per kilogram multiplied by X kilograms. Kilograms and kilograms will cancel out. I'm left with just dollars, right? $12 times X. Okay. So in other words, the amount of dollars I put in for my first part, for my Brazilian beans, plus the amount of dollars that I sell my Ethiopian beans from is going to be equal to my final blend times 15, because I said that my blend is going to be 15. So now that I have my equations, it's easy for me to solve. Yeah, and again, you can see that because these numbers are kind of big. If you try to do this one graphically, make sure you scale your graph properly. Okay, so we're not going to solve it graphically. We are going to instead solve this algebraically. So we have our two equations. X plus y equals to 200. 12x plus 17y is equal to 3,000. Okay, because 200 times 15 is 3,000. Now we want to either use substitution or elimination. I'm going to choose to use elimination because I think it's faster. I'm going to go ahead and multiply the top line by 12 on both the right side and left side. That way I can get the same coefficient for the x's and start eliminating them. So I get 12x plus 12y is equal to 2400. I'm going to go ahead and subtract the two lines. 12x minus 12x is nothing. So once again, I've eliminated my x's. Right? That's good. That's a good thing. 17y minus 12y is equal to 5y's. And 3000 minus 2400 is 600. That means y is equal to 600 divided by 5. So y is equal to 120. Now that I know y is 120, plug it back in here and we solve for x. X is equal to 80. So we have our answer. If you mix 80 kilograms of Brazilian beans with 120 kilograms of Ethiopian beans, you can create a mix that is 200 kilograms. And you will also be able to sell it for $15 per kilogram. Okay. So again, you should write a concluding statement in school. Not that important for the purpose of this class. But in school, you should write, therefore, she needs 80 kilograms of the Brazilian beans. Okay, and then 120 kilograms of Ethiopian beans. Okay, so you should write this concluding statement. And then if you do your solution like this in school, this should be worth full marks. Okay, but step 1, define your variables. Step 2, using the variables that you just defined, create your equations. Remember, each equation satisfies one condition that the problem has given you. Then it comes the easy part. Step 3 is just use elimination or substitution or graphing in order to solve it. Okay. Probably don't want to use graphing that much if you can. Okay, let's try something a little bit. Now, 8's kind of hard. We'll come back to 8. Let's try number 9. Okay, so step 1, let's define our variables. Ryan, do you think you could try defining my variables for me once again?
$1,050 per month and $1,250 per month.
So let X represent what?
The Phoenix Fashions offers.
The Phoenix Fashions offers. You have to be a little bit more specific. Okay.
Like $1,500 per month.
Okay, let's take a step back and let's just consider Phoenix Fashion offers $1,500 per month plus 0.5% commission. Let's just consider this. Okay, forget this part. Okay, this is let's just ignore that. If I asked you to write this as a linear relation for me, what would the equation be? Like, don't even worry about the variables. Just call it y equals mx plus b. Like, what would the equation be? Y equals to what? What would represent this? What's the equation that represents this scenario? If you get paid 2.5% commission and $1,500 per month, how do I know how much money you make in total at the end of the month? What equation would I write?
2.5 divide 1,500.
Not quite.
Multiply.
Okay, still not quite. Okay, I think maybe you're not too familiar with idea behind the commission, but what happens is, what this means, Ryan, is every month, the least amount of money this guy can make is $1,500. He cannot make less than $1,500. So he has got $1,500 right from the start. Even if he sells nothing, he just sleeps all day at work, you have to pay him $1,500. But he doesn't like to sleep all day at work. So he likes to work a little bit. So the work says, whatever you sell, I'm going to give you 2.5% of that. Okay, so in other words, if, for example, that month, he manages to sell $1,000 worth of items, his workplace is going to give him an extra $25 because he did a good job. Okay, so he would be at $1,525. Like this. Okay, and similarly, if he sold $2,000 worth of items, his workplace is going to give him an extra $50. It's going to be at $1,550. Does that make sense? So now my question is, what is the equation of this line? You mentioned you learned a little bit of grade 9 math before, right? Do you know how to write the equation of this line, given this information, Ryan?
No.
No, not sure. Okay, so remember, y equals to mx plus b. M is the slope, or something called the rate of change. And b is your y-intercept, or in other words, your initial value. Okay, so having established that, we know that this equation can be represented by y is equal to 0.025x plus 1,500. Where x is the amount of sales that you managed to make, right? So x is the number of sales that you managed to make, and y is your total profit, or the total amount of money that you're going to make. Does that make a little bit of sense, Frank? Yeah? So you're going to start with $1,500, and you can add bonus money to your pay. Yeah, the bonus money is the 2.5% of whatever you sell. So that's why we write that as 0.025 times x. Okay. Again, this is something that you typically learn in grade 9. So because you're not quite there yet, so you may not have had too many opportunities to do these type of word problems. Okay, but we do want to try and focus a little bit more on word problems if possible, because the algebra in grade 9 is really, really simple. You really won't get anything harder than probably like a grade 8 level in terms of algebra. It's really just, can we change a real life scenario, a word problem, into the algebraic equation. Okay, so now that we know this is the equation for Phoenix, let's try and use this knowledge in order to write the styles by Rebecca. Okay, let's try and write styles by Rebecca, the equation for that one. Ryan, did you want to give the styles by Rebecca a try? Using the same type of logic, what would the equation for styles by Rebecca be?
X equals
Y
20, 0.055 times 1,250.
No, not times 1,000. No, this is an x.
Oh, X
plus
plus
1,000.
1,250.
Very good. Okay, so we're always adding that last value, just like in y equals mx plus b, right? It's going to be adding that last initial value. Okay, so in other words, we get 5.5% of whatever we sell plus $1,250. So again, which job should we take, right? How do we know which job we should take? Well, it depends on how good of a salesperson you are. Okay, so you can see that for the other job, Styles by Rebecca, we're going to start off with less money. So if both of these people are really bad salespeople and they just sleep on the job all day, then you should probably take the Phoenix fashions because they start you at more money. They give you $1,500 just for sleeping. Okay, Rebecca is only going to give you $1,250. But the good news about Rebecca is that she pays you more commission. So you can see that her slope is higher. What that means is there's going to be a certain point eventually where Rebecca is going to be paying you more than Phoenix. Because if you're a very, very good salesperson, you should go with Rebecca because she pays you more money based off of what you sell. Okay, so when they ask you what job should Joanna take and explain your answer for these questions, you always want to say Joanna should take Phoenix if she makes less than this amount of sales. If she makes more than this amount of sales, she should take Styles by Rebecca. Okay, so the question is really just when do the two break even? And after that break even point is when Styles by Rebecca is going to start getting better. Okay, so we have a few minutes left. Let's go ahead and solve this question real fast. For this question, you can either use substitution or elimination. Most of the time for when you have the question like this, whether it's already in slope-intercept form, a lot of times people would like to use substitution. So they'll replace one y with the other y because it's already isolated, right? So we basically just write 0.055x plus 1250 is equal to 0.025x plus 1500. Now we just isolate for our variable, so we get 0.03x must equal to 250. That means x is equal to 250 divided by 0.03. So x is going to be, not sure what that is, let's find out. I think it's going to be a repeating decimal, right? 250 divided by 0.03. So we get $8,333.33. Okay, something like this. Okay, so you can see that the two of them are going to pay you exactly the same amount of money if you manage to sell $8,333 in a month. So you should take the Phoenix fashions if you sell less than this amount. If you sell less than $8,333, you should go ahead and take Phoenix fashion because as you can see here, this red line is higher than this pink one, right? But not pink one, orange one. But if you are a very good salesperson and you sell more than $8,333.33, then you should take the jobs by Rebecca because as you can see, the orange line is above the red one after that break-even point. Okay, so that answers the question for B as well. What value of sales would result in the same salary for both jobs? The answer is $8,333. If you manage to sell $8,333, you'll make the same amount of money at both jobs. Ryan, does that kind of make a little bit of sense?
Yes.
Yes, it does? Okay, good. You're a very quick learner. So don't forget how to write these equations as a linear relationship. Okay, that's really important. And then the linear system, basically, when you have here the word system, it means there's two lines, okay, two or more. So there could be more. But there's a minimum of two lines, and you're trying to find a solution by looking at their point of intersection. Okay, so make sure you understand how to do this. Make sure you understand how to define the variables. Your variables is very rarely going to just be these numbers because these numbers are given to you, right? So they're not the unknown. Usually your variable is going to be the unknown. So what's unknown in these cases? It's how much sales they're going to make. Okay, so make sure you guys are capable of defining your variables and writing the equation. If you cannot write the equation, then you're in trouble, right? Because then there's nothing you can do. You can't do the rest of the question. So getting the equation is like 90% of the battle. If you can do the equation at 90%, you're good. Okay, let's see if you guys can figure out how to get the equation for 11. Okay, so this will be our last question for the night. Let's see if you guys can figure out what to define as our variable.
Y equals 0.012 x plus 15.35.
0.35. Okay. So what's your x and what's your y? Can you tell me? That should be your first step. Your first step should be defining your variables, because otherwise your equation might not make sense, right? What do you want your x to be and what do you want your y to be?
What is gonna be
Not sure. What's the question asking for? Look, remember we talked about this. What's the question asking? Price of coffee and muffins. So what do you think x can be? What do you think y can be?
X can be a price of a cup of coffee, and Y could be the price of a muffins.
Good job. All right, bravo. All right, now that you define the variable, I'm going to ask you if your equation makes sense. Does a cup of coffee equal to 12% does a muffin equal to 12% of a coffee plus $15.35?
No.
No, right? That'd be kind of expensive for a muffin. Okay, so unfortunately that equation doesn't make any sense based off of these variables. So let's try again. Okay, Anthony, what do you think an equation could be?
X plus Y equals 15.35.
Okay, but it says 6 cups of coffee and a dozen muffins is $15.35.
6x plus 12y equals 15.35.
Good. Okay, that's a little bit more reasonable. Like one coffee and one muffin costing you $15.35 will be a very high-end coffee shop. Okay, I hope you guys aren't going to those. That's very expensive. 6 coffees and 12 muffins for $15.35. That sounds like a great deal. And that's too cheap almost. And that's a non-existent coffee shop. That's too cheap now. Okay, so that's the correct first equation. Ryan, did you want to try giving me my second equation now?
The second one is gonna be the price of so it's gonna be
Don't think too hard. First, just ask yourself, If a cup of coffee costs X and the cup of coffee increases by 10%, what's the new price of my coffee? How do I write?
Increasing X time
Times what?
X times 0.010.
Okay, not quite. Okay, close. All right. So you might have done this in school already, where you say something like, oh, if you're increasing the price by 10%, then technically you're paying 110%, right? So it's kind of like 1.1x, right? So for example, if right now your coffee costs you $2, after you increase it by 10%, it's $2.20, right? Because 10% of $2 is 20 cents. So that means we can represent the new price of the coffee by 1.1x. Okay, so that means the second equation is this. 6 cups of the new cup of coffee price, which is 1.1x, plus 12 of the new donut price. Again, the new donut price is increased by 12%, so it's 1.12 Ys. That's equal to $17.06. Does that make sense? It's a little bit tricky to think about, but you have to remember that if you're increasing something by 10%, it's like you're paying 110%. If you're increasing something by 12%, it basically means you're paying 112%, right? That means you have 1.12 times Y, because Y is the price. Okay? Similar with the coffee, you have 1.1 times that. So now we can simplify the second expression a little bit, and we can write that as 6.6x plus, oh boy, what's 12 times 1.12? I'm not sure what that is. 12 times 1.12 is 13.44 plus 13.44 Ys is equal to 17.06. Okay, and then our second equation is 6x plus 12 Ys is equal to 1535. Okay, so obviously now that we have our two equations, you can solve by using either 1, a graph, 2, by eliminating, or 3, by substitution. Okay, and that's it. You will then solve for x and y. Remember, x and y is the old price of the coffee. The question asks you to determine the new price of 1 cup of coffee. So you have to multiply the x by 1.1 and 1.12, y by 1.12 in order to answer the question, because they want the new price. Okay. All right. Hopefully that makes sense to everyone. If it doesn't make sense because you guys aren't used to it, it's not a big deal. Okay, you will be practicing this later on. And once you practice it a few more times, you will understand the concept. Okay, but make sure you guys at least understand the algebra solutions behind it. Again, we'll be practicing the algebra later on, because right now we're technically supposed to be doing these ones by graphing. Okay, technically you're supposed to be graphing all of these. So next week, in a more formal lesson, maybe I'll Google up a sheet of graph paper and we can actually graph it, or we could just graph it on Desmos. If you guys are okay with that, that'll be a lot easier. And then we can actually look up the graphical solution for these things. Okay. But make sure you guys understand that the biggest challenge is creating that expression. If you're able to create that expression, the rest is just algebra. Algebra, I'm sure you guys are strong at. Okay. All right. That's it for tonight then. Have yourselves a great night. Good job today. Anthony, Ryan, thank you guys for participating and have a good night.
Bye. Thank you.
Bye.
Thank you.
Bye. Welcome.